Hey guys, well, it's been a while. Good to see you again. I've had a bit of a few weeks to refurbish the studio, and we're back again to talk about dev stuff. And here we are. I guess the topic that I wanted to mention and to discuss was the hidden control flow. And what is hidden control flow? Well, it is the control flow of a language that is hidden from your view when you're debugging it. What happens with control flow is essentially when you have in an imperative language, something like C, C++, you have a set of statements. Those statements are generally considered to be the control flow of something, right? You have an if statement, conditional, you have various other statements that change the control flow, but you can see it. It's not hidden. You see the if statement, you see where it's going. You see a call, you know where it's going. Everything that you can step through. Now, in some languages, in particular Swift, and in some cases, I think C# and a few others, you have hidden control flow. So what happens is what you see is not what you get. What you want to see is what you want. What you see is what you get, right? As you kind of step through, you see things changing that you may not have expected. And the reason for that is because of hidden control flow. So a good example of Swift doing this is in property wrappers. You can get yourself into situations where property wrappers can make changes to values without actually clear control flow that's going on. You can also have macros that do these kind of things. And there's also sort of built-in compiled language that happens with Combine and Swift UI, which is like it's a bit of a headache to me, but it happens, it does this. So that's hidden control flow. It's like it does stuff behind the scenes that you did not expect. Now, the reason I wanted to talk about this is because I was looking at Zig, and one of the biggest selling points that they mentioned was the fact that they don't have any hidden control flow. So it's like C, what you see is what you get. And it was because of that, I think that frustration with Swift and what it's doing that made me go, well, let's have a look at Zig. Let's see what it does. What are the benefits? How does it, benefit the embedded device world, which is what I like to do, what I like to work on, as well as, say, apps and websites. But I generally prefer the kind of this is what you see. It's pretty straightforward. These are the types. C does a really good job with that. I'm not a big fan of dynamic type language. Well, not dynamic, but typeless syntax like Python and JavaScript. I prefer TypeScript over JavaScript. But if I wanted to knock something up really quickly, sometimes JavaScript is easy. But in general, for complex IoT systems, which is what we do primarily, that a type system with no hidden control flow is where you want to go. And I actually would prefer it for apps. You want to see what's being called, when and how. You want to see values changed when they get changed, not when they get changed by something hidden from your debugger or, in Xcode when you step through things. Very often you don't see things that are happening with on the side effects of property wrappers. So yeah, that's it. This is why I want to get into Zig. This is why I want to check it out. I'm hoping to do some experimentation with it. Maybe just do a bit of a linked list, do some, do the hello world thing, do linked list. But there's so many other things. I still am going to do the next video on artificial chemistries, which is what I want to do next week. And I also want to jump into just kind of more kind of exploratory streams of coding. So I want to really focus on the stream stuff. Anyway, guys, thanks for tuning in. I will see you next week as we continue on with artificial chemistries. Bye.